love a delicious apple. This is a Honeycrisp from Washington State, my home. Round, wonderful colors, delicious, all and 11 months old. 11 months of sitting in a cold warehouse, losing nutrients. What if you could go outside and pick it right from the tree? Or a tomato, or a melon. Too much work, right? But we have dishwashers, we have clothes cleaning machines, we have bread making machines. Why not a fruit and veggie machine? You walk up into the grocery store and you go to the fruits and vegetables area. And you're looking at them all and you're going, whoa, there are vegetables from Fiji, there's vegetables from Africa, there's vegetables from Mexico. But what if we could recreate the climates, the temperature, the humidity, the minerals of all those different places right here in Seattle? What if we could grow the vegetables in the climates, humidities, and temperatures here in Seattle? And we could create a Mexican strawberry right here in Seattle, locally. This is my science project. Well, sort of. This is my fruit and veggie machine. Well, the beginnings of one. Right now it's managing my spider plant, which does not produce fruit or veggies, but it is helping me get the technique down. This is the moisture sensor, this is the light sensor, and this is the temperature sensor. And this is the LCD display. Basically, all these things work together to help me figure out how to put my plant in the correct conditions. This is my LCD display. It's not very important right now, and I'll get back to that later. Right now, I want to introduce you to the technical stuff. This right here is the Edison board. It is the whole package. This is an entire computer right here in this tiny thing. This is the Arduino board, which technically the little Edison doesn't really need it. It's basically just there so that our big fat fingers can get in there and see what's going on. And this is the shield. Basically what this does is the exact same thing as this, but with a different purpose. This thing plugs in all the sensors and stuff, and it helps so that our fingers can easily plug those things in and connect it. This is the LCD display. As you can see, the plant is talking to me. It's saying, I need water. Now the moisture says it's 374. That is not really important. If you want to know what it means, look through my paperwork. Now just like I would give a child who needs water, I'm going to give my plant water. Oops, as you can see, I've given the plant too much water. That's what it's telling me. So now I know that in the future, I'm not going to use 1 cup of water. I might use 1/2 a cup of water or 1/3 a cup, but not 1 cup. So I've come back a few hours later and the moisture has normalized. And now the LCD board is green and the plant is happy again. But that's not all this experiment is about. You know, taking care of a spider plant is not going to feed the world. It's not going to end world hunger. This is just a stepping stone to something bigger. If you could imagine that this water sensor isn't connected to the LCD board, Instead, it's connected to an automatic watering system. Or the same thing for the temperature. It's connected to a heater or air conditioning. Or the humidity. And then they could all work together to create an entirely different environment.
Every day, millions of tons of produce are transported here to Seattle. But with a $20 computer, we can reproduce the conditions that those produce came from here in Seattle, locally. And by recreating the produce's ecosystems, we can eliminate the need for the planes, trucks, and trains. And by doing that, that may eliminate the greenhouse gases, which eliminate global warming.
Next time you're at a place like this, imagine where this stuff came from and imagine growing it locally.